Hi, this is Miss Park. This video is called Reflections. So reflections is another kind of transformation. You might remember reflections from last year from working with parabolas. So here we are in the booklet. Here's a function that we don't have an equation for it. It's not one of our parents, but we just have a graph and we're calling it f of x. So this first part here says, given the graph of y equals f of x, graph y equals negative f of x. So what is negative f of x? It means, remember, x is your input, f of x is your output, also known as y. If we put a negative in front of y, essentially we are changing the sign of all of the y values, or in other words, we are multiplying all of the y values by -1. So if I was to write the mapping rule for this, it would look like every point xy becomes no change is happening to the input, so x is still x, but the y's, once we get a value, we're going to multiply by -1. That's the mapping rule. So let's see what that looks like on the graph. So let's take each point. So I have a point here that is, so this one here is -4, 2. If I take that point -4, 2, and apply the mapping rule, my new point is going to be -4, -2. So I'm going to have a point there. Here's 0, -1. Apply the mapping rule. I'm going to get 0, +1 over here. And what I'm going to do, I'm just going to connect these dots as I find them so that we can see what the resulting graph looks like. All right, here's the point 4, 1. So apply the mapping rule. I'm going to get 4, -1. I'll connect dots. And here is 6, -3. Apply the mapping rule. I'm going to get 6, +3. All right, and what I've created, this new graph, looks like this. And it is a reflection of the original graph using the x-axis as the mirror. Okay, so it's a reflection in the mirror using the x-axis. So the way to say that is we can say reflection in the x-axis. You'll probably find more frequently, I would usually say vertical reflection, but they're both correct. A vertical reflection, it sounds like it's opposite because I'm saying vertical, but I'm saying x-axis. But vertical reflection means it's reflecting this way. Okay, like this way to here. Okay, so that's vertical. And so that is my graph. And so I'm just going to label it. So this was y equals f of x. This is y equals negative f of x. And I don't have an equation because it's not one of our parents. It's just a graph. All right, so let's see what a different type of reflection looks like. So it's the same f of x as before, only this time the negative's on the inside, which means it's affecting the input. It's affecting the input. And we want to see what does the input have to be in order for the y's, or the output, to stay the same. So I want this point xy to become the same y. So what has to happen to the x's so that when I make them negative, they come back to the same x's as before, which produce that y. So I will have to turn these x's negative or change their sign. I'll have to change the sign of these x's in order to produce the x's from before, which will give me those y's. So it's a similar idea to why with translations, we go left and right. So a little bit backwards. So now I'm going to take my points. So -4, +2 is now going to become +4 and -2. So I have -4, and I have +2. So I'm going to make a point at 4, 2. And then my point 0, -1 is going to become 0 still, and -1, because -0 is still 0. So I'm going to connect these dots. Next I have the point 4, 1, which is now going to become the point 4, -1. sorry, 4, 1 is going to become negative 4, positive 1. So negative 4, positive 1 is here, and I'm going to connect the dots. Okay, and then the last 0.6, negative 3 is going to become negative 6, negative 3. Okay, and then what I'm left with is this like tarantula-like thing. But basically you can see that the graph has been reflected using the y-axis as the mirror. So it's reflecting from side to side, and not from up to down, but from side to side. And so we call that a horizontal reflection, or a reflection in the x-axis, in the y-axis. Okay, so when we say in the whatever axis, it means using this axis as the mirror. All right, the last thing here is the word invariant. So the question's asking us find any invariant points. The meaning of invariant means does not change as a result of a transformation. And hopefully you'll remember that because of the word vary. So I'm just going to finish this. Okay, invariant, the word vary means change in English, and the part that says in means doesn't or not. So it does not vary, it does not change. So these points don't change as a result of the transformation. So is there a point that didn't change as a result of what we did? And that would be the point 0, negative 1. Okay, so 0, negative 1 didn't change when I applied this transformation. Okay, it states 0, negative 1. And how about here? Are there any invariant points? Were there any points that didn't change as a result of the transformation? So there were none. Okay, and so that's reflection. It's not bad at all. This exercise down here is asking us to graph. So this is a good reminder of how to graph parabolas. So it's graph this parabola, find the roots and the vertex, and then it wants you to write the equation for these two and sketch them. Let me just review how to graph this one. So hopefully you know f of x equals x squared plus 6x can be factored into x times x plus 6. So now we have our x-intercepts are 0 and negative 6. One here, one here. The vertex is halfway in between 0 and negative 6, so it's negative 3 something. So I know it's on this negative 3 somewhere there. You'll want to know what the vertex is, so let's plug it in. Let's plug negative 3 into the equation, and we get negative 3 squared plus 6 times negative 3, so that's 9 minus 18, which is negative 9. So we know the vertex is at negative 3, negative 9. So I'll make the dot here, negative 3, negative 9. Okay, and now I can actually sketch the parabola, but we know that a good parabola has 5 points, not 3. I notice that the a value is 1, which is means it's the same shape as the parent. So from the vertex, I can just go 1, 1, 1, 1. I could even go 2, 4, 2, 4, and sorry, it's not 1, 1, this is 2, 1. And then on the other side, also go 2 and 1, 2, 3, 4. Okay, now I got lots and lots of points for this. Okay, I'm going to draw it, I'm going to extend, and I'm going to label it. I'll call it y equals x squared plus 6x. Okay, now it's asking us for the equations of the other two. So let's do the first one. So I'll call this 1 and I'll call this 2. And I'll do it in different color. So 1 would be y equals negative f of x, but f of x is x squared plus 6x. So this is x squared plus 6x, which is negative x squared minus 6x. That's going to be the graph of the vertical reflection. But because we know this is a vertical reflection, I don't have to go through all the work of how do you graph this thing. I can just take every point that's on this one here and reflect it vertically. So I can see my 0, 0 will stay 0, 0. My negative 6, 0 will stay negative 6, 0. my -3, -9 will become -3, +9. So remember, all the y values are going to change sign. We were multiplying them by -1. And then this one over here, that's -4, -8 is going to be -4, +8. There'll be another one on the other side. And now I've graphed it easier using the transformation. And I will put the equation here, y equals -x² minus 6x. Okay, we'll just do the last one, change my pen. F of negative x, y equals f of -x. So f of -x is what you get when you substitute -x into f. So instead of all the x's, they're going to be negative x's. I'm changing the input. And that's going to be x² minus 6x. Okay, but that's just a horizontal reflection, which means my graph is going to reflect horizontally. So 0, 0 will stay 0, 0. Okay, and then -6, 0 will become +6, 0. -3, -9 will become +3, -9. So all the x's are being multiplied by -1. Let's take one of these points. -2, -8 is going to become +2, -8. I know I have another point here. I can now draw the whole thing. Okay, and so let's extend this a little bit further. And I'm going to label it with the equation that I got. Last thing is it's asking for any invariant points. So my original one was blue. For my pink one, which was the vertical reflection, were there any points that stayed the same? So there were. -6, 0 and 0, 0 were invariant, because if I make the y's negative, or if I change the sign of the y's or multiply the y by -1, 0 times -1 is still 0. And for the other one, which ones are invariant? For the green one, 0, 0 for sure, because if I multiply my x by -1, I still get 0. I think that's the only one. Okay, that's reflections. Thank you.